In the previous lesson, we explored regression to the mean. Now we examine another powerful distortion that often masquerades as psychology: scale effects and estimation bias. Sometimes what looks like overconfidence is not ego, it is measurement structure. To understand this, we must first understand how scales work. When people evaluate themselves, they often use rating scales. For example, rate your skill from 1 to 10. Rate your performance from 0 to 100. Estimate your percentile rank. These scales seem neutral, but they are not psychologically neutral. They shape perception. Let's begin with scale compression. Most people avoid the extreme ends of a scale. Very few rate themselves as 1 out of 10. Very few rate themselves as 10 out of 10. This creates central clustering. Ratings compress toward the middle. Now consider what happens when actual performance distribution is not symmetrical. If real performance varies widely, but perceived ratings cluster tightly, distortion appears automatically, not because of ego, because of scale behavior. Next, consider ceiling and floor effects. If a test is easy, many participants score near the top. If a test is hard, many score near the bottom. In both cases, differentiation becomes limited. When differentiation is limited, relative ranking becomes unstable. Now imagine asking people to estimate their percentile. If performance differences are small but perceived differences feel meaningful, estimation errors increase. The scale exaggerates subjective difference. There is also a well-documented bias called central tendency bias. When uncertain, people choose middle values. This reduces extreme self-ratings. Ironically, this can create artificial underestimation in high performers. If someone truly performs at the 90th percentile but avoids rating themselves at 90, their estimate shifts downward. This appears as humility, but part of it may be scale caution. Now consider range restriction. If participants come from a selective environment, for example, high achievers in a competitive field, actual ability range narrows. Everyone is relatively strong, but subjective perception may still feel average. In restricted ranges, small performance differences appear large psychologically. This affects calibration curves significantly. Another important concept is reference group bias. When estimating performance, people do not compare themselves to the full population. They compare themselves to their immediate environment. If you are surrounded by high performers, your self-estimate may decrease. If you are surrounded by lower performers, it may increase. The same objective skill can produce different self-ratings depending on reference frame. This is not ego distortion, it is comparative distortion. Now let's examine percentile misunderstanding. Percentiles are not intuitive. If someone scores in the 60th percentile, they are above 60% of people. But many interpret percentile as percentage score. This confusion inflates or deflates perceived competence. Scale misunderstanding produces artificial gaps. There is also a psychological phenomenon called anchoring. When unsure, people anchor estimates to familiar numbers. For example, many default to around average. Average feels safe. Safe feels reasonable. But average is statistically specific, not emotionally neutral. If 70% of participants rate themselves above average in a skewed skill distribution, this may reflect misunderstanding of distribution shape rather than collective delusion. Scale structure matters. Measurement design matters. Statistical literacy matters. Now reflect. When you evaluate yourself, what scale are you using? Is it defined? Is it relative? Is it based on objective distribution? Or is it intuitive and emotional? Many apparent self-perception errors shrink when measurement improves. Psychology and statistics interact. Not every confidence gap is ego. Sometimes it is estimation bias. Sometimes it is distribution misunderstanding. Sometimes it is scale distortion. This does not invalidate psychological insights, but it reminds us, before diagnosing ego, examine measurement. Clear thinking requires both psychological and statistical awareness. In the next lesson, we move deeper into a controversial question. When is the Dunning-Kruger effect itself partly a statistical artifact? Because true intellectual maturity requires examining even popular theories with precision. Calibration continues.